Part 2 of this video has to deal with the ideal gas law. Now, this is a gas law that deals with the properties of an ideal gas where we have a pressure, a volume, the number of moles, and then we use the R letter for the gas constant, and then times the temperature. So this is an equation right here that we have seen before, and it combines Boyle's, Charles, and Avogadro's law. So it's putting all three of those together into one equation. The nice thing about this equation is we can get moles, and just like before in stoichiometry, when we could solve for moles, then we can convert from any other substance in the balanced equation. So that's why this equation is really good to use, is because it has the moles in it. Now, just to talk about that letter R, it is the ideal, it's the gas constant for the ideal gas law. Now, it has two different values, but the only reason it has two different values is because the only unit that's different here is for pressure. This one is in atmospheres and this one is in kPa, and it's just because we have so many different units to measure pressure in that we have different R values. These are the two most common ones. There's an R value for if you use PSIs, but that's an English unit, and we like to stick with the metric. So these are the two most common R values that we will use. If you need these, I will give those to you. So one example of doing a problem with this. So one way to recognize a problem like this is the fact that there isn't a change in pressure, or there isn't a change in temperature or volume. So you're not having an initial condition and a final condition. It's just stating there is a pressure, there is a temperature, there is a volume, there might be the moles that is given to you. So notice there is not a change from initial to final. So the problem here is just stating, it says at what temperature will 0.645 moles of neon gas occupy 12.3 liters at 1.95 atmosphere. Notice there's not a change in any one of the variables. They're just stating moles, volume, and atmospheres, and they're asking you temperature. So we're going to need to use this equation, the ideal gas law. They want temperature to be solved for, so we've got to get rid of nR. Got to do the same thing over here. So my equation ends up being PV divided by nR equals T. So I just need to fill in my variables. My pressure is 1.95 atmospheres. My volume is 12.30 liters. Over my moles was 0.654 moles. And then my R value, since I'm in atmospheres, I'm going to have to use the one that has atmospheres in it. It is 0.0821 liters times atmospheres over moles times Kelvin. A lot of units on that. So moles is going to cancel, atmospheres is canceling, liters canceling. I'm left with Kelvin for my units. Did my math, I got 446.7 Kelvin, and it just said what temperature, so it didn't ask for it specifically Kelvin or Celsius. If it did, you'd have to convert it to Celsius. And if I look at, I have 3 sig figs here, I have 3 here, and I have 4 here. I'm multiplying and dividing. It must be the one with the least, so the answer would be 447 Kelvin. Okay. Now, I'm going to go to my next slide and do another problem. This one is just a continuation of the ideal gas law. So, notice on this one, all they told you was determine the volume of 1 mole of the gas at STP. Now, STP conditions are 0 degrees Celsius, which is 273 Kelvin, and pressure is 1 atmosphere, or 760 millimeters of mercury, whatever those pressure conversions are that we have. So they just want to know, what is the volume? So if I go to my equation here, I'm not changing my variables from an initial to a final. I'm just asking what is the volume. So I want to solve for this. So I'm going to divide by P. Divide by P. It looks like my equation is nRT over P equals the volume. So I'm going to fill in my variables. I have 1 mole of this gas. I like to use the atmosphere R value. And the temperature is my temperature here in Kelvin. And my pressure is 1 atmosphere. So, do my math on here. It looks like it comes out to be 22.4 liters. That is the accepted value for 1 mole of any gas at STP. Because if you change for the volume, if you change the temperature or the pressure, the volume changes. Okay? So this is a way that we can convert a gas to moles by using that conversion. I did a lab which I collected close to that, and you should watch that video. So it says, did the example in 5 describe a particular gas? No, it did not. So for all gases, 1 mole is 22.4 liters at STP, and that is only at STP. So the molar volume of a gas. So just relating this to some other substances. We know we can do molar masses of a substance, a compound or an element, and this would be a solid. We know 1 mole is this many particles, Avogadro's number. We've also shown you that lab experiment. I did have some error in there. That was about 6%. And we can say that 1 mole of any gas at STP is 22.4 liters. So that's going to be our conversion that we're going to use for our gases. So here's a simple conversion for a problem. They said you have a volume of 3.5 moles of carbon dioxide at STP. And I just put the conversion up there that we know that 1 mole of any gas occupies 22.4 liters. So I could say 3.50 moles of CO2 times, I want to convert this to volume. I know at 22.4 liters, and this is at STP, there's 1 mole of CO2. Do my math here. I have 78.4 liters of CO2. And this would be at STP. Because that's the conditions. So now I'm going to do another problem here. And this one is going to relate stoichiometry to our gases. Okay? Now, notice in this problem, just like with all our stoichiometry problems, the first thing we need to do is write out the equation and balance it. So I'm going to start with that. Zinc, that's a solid, plus hydrochloric acid. This is what I did use in my lab video, AQ, yields hydrogen gas plus zinc chloride. I need to balance my equation. So to balance, I need this. And there's my equation written out. Now, I need to also look at this. I have 1.13 grams of zinc, and they're asking me what volume of hydrogen gas is, at those conditions, is going to be produced. I want to know this, and I want to know it in liters because it says volume. Okay, now, here's what we do. We either do stoichiometry first from what we know before, or we use the ideal gas law. In this case, since we have mass of zinc, we can take that and we can convert this zinc. Look at, this is a 1-to-1 ratio. So if I figure out moles here, can't I know moles of hydrogen? I should be able to know that. So I'm going to start with, so I'm going to go step 1. In this case, this isn't always true, I'm going to do stoichiometry. I'm going to just write Stoich. So I'm going to start out with 1.13 grams of zinc times, I'm going to convert zinc to moles. 1 mole of zinc is 65.38 grams of zinc. Times, don't I know it's 1 mole of hydrogen to 1 mole of zinc, right? This is 1 to 1. When I do my math, I got 0.01728 moles of hydrogen. Okay, now I know my moles of hydrogen, and I want to collect this gas at these conditions. Notice they put conditions there of what I want to collect my gas at. So step 2 is going to be, I'm going to use this equation, because this equation is for gases, because it's the ideal gas law. And now I know this mole value here, and look at, I have my conditions. I want it at 1 atmosphere, and I have temperature, and I know that R value, that's a constant. I can figure out what volume I want. So if I rearrange this equation, isn't it V equals nRT divided by P? Okay, because this is what they're asking me to find right here. So if I put in my values, my moles for the hydrogen is 0.01728 times R, 0.0182, no, it's 0.812. And then the temperature is at 25 plus 273. Isn't that 298? Over, my pressure is 1 atmosphere. I do the math for this, calculate through that. I got 0.423 liters of hydrogen. That would be my answer. And it should be 3 sig figs, because I have 3 here, I have 3 here, and when I convert 25 to Kelvin, it's 3. So that should help you. Sometimes in these stoichiometry problems, you are going to have to first use this to get the moles of the gas, and then use the stoichiometry to solve for whatever the other substance is that they're asking. So you have to decide, do I do stoichiometry on a mass first, if they gave me a mass? Or if they gave me more information about the gas, do I figure out the moles of the gas and then convert to moles of another substance?